for coming. My name is Dustin Nest. I'm StreamNative's technical trainer, and today I'll be talking about StreamNative's Ursa engine and the built-in catalog integrations, how this is a cost-effective way of streaming direct to lakehouses. And again, my name is Dustin Nest. I've been with StreamNative for almost 2.5 years. You can read a little bit about my background, but I'm our technical trainer. Worked a lot in C++, C Sharp, Java, JavaScript, React, and it says here, I'm excited to be your guide as you learn how to build scalable messaging and streaming applications. That's what I typically do in my job here is I do a lot of the training courses. You may also have seen me on our StreamNative Academy YouTube channel, where I give a ton of demos and walkthroughs of how to use a lot of our products. But as I mentioned, today I'm going to be talking about the StreamNative Ursa engine and how it helps us create a streaming augmented lakehouse with catalog integrations. In particular, we have integrations with Databricks Unity Catalog. So published data, not only does it show up in S3 buckets or in GCP or in Azure, and you can query it, but it actually registers those tables directly with the Databricks Unity Catalog. So when you hop into Databricks and want to start using that data, it's easily findable. We also integrate directly with Snowflake Open Catalog, which I'm going to be demonstrating that one today, and Amazon S3 Tables, which I'll also be demonstrating that one today. But today I won't be going through the Databricks Unity Catalog demo, but I have demos of all of this, again, on our StreamNative Academy YouTube channel. We're going to go a little bit into an architecture deep dive, but tons of demos. So the key is I want to show you when I publish data, what it looks like in the storage backend, and then how easily it is to query it in one of those external catalog integrations. We're not going to be going through the setup of a cluster today. That takes more time, but I will have some slides at the end about what it takes to get started and how you can get started with building one of these yourself. So first, let's do a quick introduction to StreamNative Ursa and what a streaming augmented lakehouse is. So the StreamNative Ursa engine, it's 100% compatible with the Kafka API. It provides a leaderless architecture, with the removal of bookkeeper and zookeeper as well. So leaderless architecture basically means that any of your brokers can service any topic at any time. So what that does is it's a huge cost savings. And I'm not going to be talking about cost savings at all in this talk, but that is a huge benefit of the Ursa engine. Because any topic can service any broker can service any topic. That means no matter where your clients are, they're able to connect to a broker in their same availability zone, so it reduces a lot of the traffic. We also have removal of bookkeeper, so we use direct object storage, which is going to have a huge cost savings. And then bookkeeper is available for low latency applications as well. And instead of zookeeper, we use Oxia as the backend. That also helps with the leaderless architecture because there needs to be some coordination between the brokers if they're all receiving data or multiple brokers are receiving data for the same topic to keep message ordering across those brokers. So we do build directly on object storage, but it takes it one step further. It actually ends up creating a streaming augmented lakehouse. So it unifies data streaming and data lakes because we're saving the data directly in an open format. So when the data comes in, we actually save the data very quickly into what we call an Ursa format. That's required so that we can go back to the producer and say, hey, I've acknowledged that I've received this message. And for streaming applications, it's incredibly important to do that very, very quickly. But in a short time after that, we actually will sort the data into Parquet files, which is going to be your Delta Lake and your Iceberg formats. And then that data will be made available through commits to the tables. Then you'd be able to read it through external applications that want to be able to read that data in those native formats like Delta Lake and Iceberg. But we take it one step further where not only when we create the table does it show up as Delta Lake and Iceberg, it actually then registers that also as a built-in catalog integration. So if you've set up your Ursa cluster and its backend to link into Databricks, the Databricks Unity catalog, the new table would show up automatically on the Databricks platform as soon as you created it inside of our cluster. And once the Parquet files start forming, that table will show up. And then as new Parquet files are created and registered, the new data will be available through, for instance, SQL queries or any other application that you're running in Databricks. For Snowflake Open Catalog, I'm going to be showing you that one today. Open Catalog is kind of a separate application almost from Snowflake. So I'm going to show you what it looks like when the table first shows up there with its registered schema, and then how to be able to read that data inside of Snowflake. I've already set up some of the integrations where you have to do an external location and also a catalog integration. But then once you've done that, all you do need to do is register each table. And I'll actually show you that as well. Then Amazon, instead of just S3, they have something now called S3 tables, where I then am able to query the data through Athena. So I'll be showing you that as well today. So streaming augmented lakehouse and catalog integrations. Let's take a little bit deeper dive into what that looks like. So as I mentioned, we are working, or we integrate directly with Databricks Unity Catalog, Snowflake Open Catalog, and Amazon S3 tables. Over here on the right, there's a little bit deeper of the data flow and the control flow. But what you think of here is on the top left diagram where it says StreamNative, Apache Pulsar, Kafka topics, you would be publishing messages. And today in the demo, I'm going to be using IntelliJ to publish Kafka messages direct to topics. As I'd mentioned, instead of using Bookkeeper as the backend, it goes directly into object storage. So a little bit later, I'm going to say which of these catalog integrations are compatible with each of the service providers. But if it's S3, Google Cloud, or Azure, it's going to be saving that data as either Delta Lake or Iceberg formats, depending on which vendor or which of the catalogs supports each one, into Parquet files and any of the metadata that's required to register those Parquet files as well. So that's all going to be in object storage. So direct to object storage. But at the same time, we want other applications to be able to read that. So on the far right, we have Databricks, Snowflake, or AWS. And those are Unity Catalog, Open Catalog, or in the case of AWS, it's called Amazon S3 tables. To get that data out of those Parquet files, you don't want to have to manually go find where they're located, things like that. So the StreamNative cluster also reaches out directly from the cluster into Databricks, Snowflake, or AWS to register those tables inside of those catalogs. So it makes it much easier. You don't have to go find the data inside of the Parquet files. StreamNative knows where it wrote those Parquet files. It knows what topic it coordinates with. So it also, or it corresponds to. So it also goes over to Databricks, Snowflakes, and AWS and registers those tables. So all you need to do, you never have to really go back in the back end and look at the Parquet files again. You're basically publishing into StreamNative, and then you're reading out of Databricks, Snowflake, and AWS as topic names, never really caring where the Parquet files are stored once you've set up your cluster. So we're going to be looking at that as well today, what some of that backend looks like for Snowflake in particular. Here's a demo flow. This example is Databricks, but as I had mentioned, today I'm going to be doing Snowflake and Amazon S3 tables. So here on the far left, I have some sample data. That's going to be our producer in IntelliJ. I'm going to be using Kafka to produce into our Ursa cluster. Into that second blue box, which is our StreamNative topic. The Delta table is going to get created, the Unity table, and then we're going to commit the Parquet files. That's going to reach out to Databricks then to create the Unity table. StreamNative is going to be writing the data into Parquet and that low-cost storage in the middle. So we create the Delta table, commit the Parquet files there, and then Databricks is going to be able to read data from those Parquet files. So StreamNative is writing into that Delta Lake and Databricks is reading out of it, all based off of the information when StreamNative created and registered that Unity table into Databricks. Then you basically are able to run your SQL queries or any other application directly in Databricks. So on the far right, you're able to query that data. I think we're ready for our two demos. So let me go ahead and start up the Snowflake demo first. So I'll bring up IntelliJ. So here I have IntelliJ open. I'm going to be using two sets of producers and consumers. So this is the Snowflake Open Catalog set here. Let me go ahead and open up my client.properties file. I'm going to be publishing to a topic called Kafka test 7. So let me go ahead and start up that producer. It's going to produce one message per second. And I just want to get that started up. And then I'm going to start up the consumer as well, just so we see that this data is acting as a normal streaming system. So even if you are going to be using this as a streaming augmented lakehouse, these topics still work as regular streams with producers and consumers, just as you would expect. So let me start up that consumer. should consume up to message 20 or so. There it goes. So operating as a normal streaming system. I'm going to go ahead and stop the consumer here, and we'll let that producer keep right on going. Again, it's about 1 message a second, so you can kind of see the progress that it's making as we move into the next step of now looking at the back end. So here I've gone over to StreamNative.io, and I'm inside of that cluster. It's the Snowflake instance Snowflake cluster. If I go over to the configuration page, you'll be able to see that there's the bucket location that this cluster is set up to use. This is where that data is going to be stored both initially in the Ursa format as well as long-term in the Parquet format that is going to be readable as Delta Lake or Iceberg. And in this case, since we're using Snowflake, it's going to be an Iceberg. The Snowflake Open Catalog warehouse that I'm using is training, and we'll see that when we hop on over into the Open Catalog. If I go to tenants, public, namespaces, default, topics, you can see Kafka test 7 has now been created, so we're starting to publish data to that. So let me go ahead and now look in the S3 backend that we had talked about, where that data is going to be in S3. So here in S3, I'm going to go ahead and go to the training Snowflake bucket that I'd mentioned where the backend is. If I go to test, that was the subfolder that I was in. I go into compaction, and then it goes to the tenant and namespace. You can see that Kafka test 7 has already showed up. It's actually tunable on the cluster. Right now, I think this cluster is tuned to take about 2 minutes for the data to start showing up here. Metadata is going to be your JSON, Avro, all of the registration of the Parquet files into the topic. And if I go to the partition, and then here you're going to start seeing the Parquet files forming in that compacted form that's going to be readable by Databricks. We have 3 files here. You can see they're showing up about once a minute. So initially it might take 2 minutes the way this cluster is currently tuned, and then new data is showing up once a minute if I continue to publish. So that means when I'm in Databricks, I would only expect if I were to run the SQL query multiple times, only once a minute would it start to show up the new data. So at this point, it's now time for us to head over to Snowflake Open Catalog to look at that training warehouse as well as the schema registered for this topic. So here I am in Snowflake Open Catalog under Manage Catalogs. Actually, I'm going to go up to Catalogs here on the left. You can see that there's 2 catalogs, StreamNative and Training. We're working in the training warehouse. If I go ahead and open it up and I go to public, default, and you can see that the Kafka test 7 topic has automatically showed up for me. And I was using an Avro schema. And because of that schema, this is actually, the data is going to show up in columns. This is just the schema shown here in Open Catalog. To actually see the data in the columnar format, I'm going to execute a SQL query over in Snowflake. So here I am in Snowflake. As I mentioned, to get this to work, Snowflake and Snowflake Open Catalog don't integrate directly or automatically. In Snowflake here, I've had to create an external volume as well as a catalog integration. Once you've done those 2, then you can register that. You just do that once, and then I have to register each table. So I've already got my warehouse turned on, and I'm going to register a new table, the Kafka test 7, and I'm going to register that as a table called Kafka test 7 inside of a training.demo database that I have here. So we're going to make that reference, and it knows where to look in the Open Catalog, and it knows where the Parquet files based off of the external volume and the catalog integration I've already created. I didn't show that here, but if you want to see how that's done, I have very extensive videos on StreamNative Academy showing how to set all of that up. But so now that the linkage has been made for the new table, so every time you create a new table with Snowflake, you have to add that linkage in. I can now go over to the query table. This is for Kafka test 6 here, but as I had mentioned, this was for training.demo. If I go to Kafka test 7, I can go ahead and execute that, and we'll see that the data is now showing up. We're already up to a value of 274. If I were to wait about 60 seconds or so, that next Parquet file would have registered, and we should see more data. We could probably do that in just a second here, but I would like to show that if you go to table count, now that we're seeing things as tables, we can do other types of queries. So in this case, we can do a count query that you wouldn't normally be able to do easily on a stream. So let me go ahead and execute that. And you can see now we have 334. So in the time I ran the regular query to the count, and probably another Parquet file got registered. So if I go back to query table, I'd expect that we probably are up to 334 or whatever that number is. Sure enough, we are here. Of course, I'm ordering by the publish time descending. So that's our Snowflake Open Catalog demo and how the data that you publish with Kafka automatically gets created or gets put into Parquet files, registered as tables, and is queryable. I wanted to show a second demo quickly on Amazon S3 tables. So I'll go back to IntelliJ. So here in IntelliJ, I'm going to stop this producer, and I'm going to be using a separate one. This one I'm going to be publishing to Kafka topic 3. And I have it already set up here to publish to a different Ursa cluster that is set up with S3 tables. So my producer here, again, once a second, my consumer here, I'm just going to confirm I have a different consumer group ID. Sure enough, I do. So I'm going to execute this one, which is pointing to a different Ursa cluster. And let me also execute the consumer. Once these are running, and we know that everything's working with these two, I'm going to then head on back to StreamNative UI, and we're going to take a look at that cluster real quick, and then we'll hop into AWS. So here we're publishing messages and consuming. I'm going to leave this running as is. Here I am in StreamNative or the StreamNative.io in the UI. Here's my AWS instance, AWS cluster, Ursa cluster. I go ahead and go to the configuration on this one. You can see it is using a different storage bucket. This is actually the default bucket that is created by the BYOC cluster. It's also an Iceberg format, but the warehouse here is S3 tables, and it's called my S3 table bucket is the name of that S3 table. I go to tenant, public, namespace, default, topics. Here's our Kafka topic 3 that we just started publishing to. It's going to take about 2 minutes again for this cluster to show up in AWS. So let me head over to the S3 tables, and we'll see if this topic is showing up there yet. So here I am back in AWS. Instead of in regular S3, I went to the table bucket. So that folder that I was showing you, the regular S3 bucket, is where the data is going to be stored first in the Ursa format. Once it's compacted, it's going to go directly into the table bucket. Here's my S3 table bucket that I showed you. Kafka topic 3 is already showing up here. So what I'm going to do now is head on over to Athena. There's actually a process using lake formation to get this data queryable in Athena. Again, I have YouTube's videos on that on StreamNative Academy. But I'm just going to go straight to Athena here and try and query this data since we've registered the table. And when I mean table in this case, I mean the actual Kafka topic. So I was in here working earlier, so it already selected the correct catalog, the correct database, which is going to be a concatenation of the word pulsar with your tenant and namespace. But the table, these are going to automatically pre-populate here as more tables get added, which is basically the equivalent of topics. So if I expand this, you can see that there is some schema information. And if I go ahead and switch out my query to say Kafka topic 3 and I run it, the data is going to be queryable here. I did do an order by descending, so only the first 60 seconds worth of data has shown up, 58 messages. If we go ahead and wait a little bit longer, every 60 seconds, I would expect that more data starts to show up here as well. So getting back to the presentation here, we've done 2 demos. The first one is the Snowflake Open Catalog demo, where we publish and consume messages using the Kafka protocol. We hopped on into the S3 backend, and you could see the Parquet files in object storage. And then there was a new one that showed up every 60 seconds. Again, that's all tunable. And then we queried the data in Snowflake through Open Catalog. The second demo, we used Amazon S3 tables, publish and consume messages using the Kafka protocol, just like a normal streaming engine. We went into the S3 tables portion of S3, and you could see the topic had shown up there. And then because, which I'd not shown as part of this, the lake formation setup, we were able to query the data inside of Amazon Athena. And then again, we did not demonstrate the third option, which is to use Databricks Unity Catalog, but I have demos of that as well on YouTube. Ursa is available. So how do you get started if you're interested in this? Ursa is available as a StreamNative BYOC. So it's going to be in your cloud environment, but we manage the cluster. There is a $200 free trial, no credit card needed. Again, there's the Databricks Unity Catalog integration. It currently works with AWS and GCP. So if like Open Catalog integration works with AWS, GCP, and Azure, and then the Amazon S3 Tables option is available on AWS. We have documentation here linked in for those, but in addition to the documentation, I have a ton, as I mentioned, a ton of YouTube videos on all three of these at Stream Native Academy. Again, here's the QR code for the $200 free trial. If you're interested in getting started, BYOC would require some special permissions into your cloud environment or into your cloud provider. Then we do what we call the deployment of a cloud environment, which is basically the Kubernetes cluster and all of the observability components so that we can monitor that cluster. If you want our help getting started with that and possibly talk about a POC, that's where you would want to book a demo to get in contact with our sales team. In fact, that's just going to be the route, even if you just want to talk to them about different features on our different clusters. So that's going to be streamnative.io with book-a-demo, and you can see the link at the bottom of the screen. Again, uh, that's the best way to get started. So I want to thank all of you for listening to the talk today, and I hope that you enjoyed the demos. As StreamNative's technical trainer, I love to do demos all the time. I want to demo all the products when I do presentations. And at this point, it leaves it open for questions. Hello, everyone. Thanks for coming. If you have any Q&A, please drop them in the chat. I'll go ahead and try and answer them. I'm both the speaker for this session as well as the moderator for this series, for the user series. So it's just going to be me in here. A few questions did come in already, and I tried to answer some of them. Uh, the first one was, who manages the table lifecycle? Is it done by Ursa itself or the catalog provider? Um, One of the main things that I didn't talk about is the concept of external versus internal tables. Some of that depends on which of the three catalog integrations you're using. And also, there is the option to not use a catalog integration at all. You can just write directly into Iceberg or Delta Lake. So that's also another option that is not mentioned in the talk. But when I refer to external versus internal tables, external is external relative to Ursa, because then that would be internal to Databricks, for instance. So when I say external or internal, everything is managed by Stream Native, and there's one copy of the data. That copy is used also to back the streams. So the data that you would read historically would also read through out of the Parquet files as well. When it's in that scenario, you're much more limited, or you have to be much more careful about maintenance because it has to remain completely compatible with the reads from the streaming engine. One of the questions that came in, can you use your own compaction tools? I'm not exactly sure for the internal table if that's allowed or not. I do know that for internal tables, because some customers do want exactly just one copy of the data to greatly reduce cost. Engineering is working with them on what options we have available for compaction. Although if you don't do any sort of further compaction, you're going to end up in the situation where the initial frequency that you write the Parquet files in, if it's once a minute, I think was the example I did in the video, which the engineering team had tuned the cluster to, then that would just be the Parquet file frequency that you have, and then you wouldn't be compacting those further. With an external table, it's a second copy of the data. Uh, Amazon S3 tables is always an external table in that case. So it will always make the Parquet file and copy them over. If you went to the session just before this, um, the Amazon S3 tables architecture, use cases, integrations, they talked a lot about the optimizations they do. That's basically exactly this scenario that I demoed where you are using Amazon S3 tables, always an external table. They're always doing the maintenance. And then she actually had talked about Spark does some of the maintenance, but some of it is some internal stuff that she didn't want to talk about. That's going to be that external table option. I believe for Snowflake, we have both internal and external options. And I believe for Databricks, I think it's always an internal option right now, internal to Ursa, because I think there's an API that needs to change on the Databricks side. But I know customers are working very closely with Stream Native and Databricks and Snowflake on their compaction options and maintenance options because everyone does want to do maintenance on these tables. And then the Amazon S3 tables, there's not as much question about that because they just always do the maintenance. And as she mentioned today, she can talk in depth about what types of maintenance they do. For instance, like which type of optimization algorithms. So I'm not sure about using your own compaction service, but if you are interested in Ursa, please get in touch with our sales team. They will very quickly put you in contact with Hong, who is the main backend engineer for this. And he's talking to all of our customers about exactly how they want to do maintenance on these tables. Um, the next one that I see is how is compatibility with schema evolution? I put a link into the Q&A showing the current feature set. But Ursa is evolving very, very quickly. So right now, schema evolution is not currently supported, but I believe in one of the webinars that we had done about Ursa, it is on the roadmap. But I would definitely get in contact with me if you want more clarification on that. Kunin is the moderator in the other session, is who I would also talk to about that because we've been working very closely on engineering. He more so knows the roadmap. Um, so if you do want to get in contact with me for a clarification on that, I'm going to put my email in the chat. Um, if you have any other questions you have about Stream Native Ursa, I'll get you in contact with Kundin, or I'll go directly to engineering, who I work with on creating all these demos. It's been very exciting to work on this. I hope you guys found it very interesting. It's amazing sometimes to see that you just publish data that you previously would just make microservices, but now suddenly it's just available in table format. And um, while there is initial setup, which is a lot of it is setup of permissions because the catalog, there's going to be the catalog integration. So Stream Native needs to be able to reach out to the catalog to create the table. And then the other permissions is both Stream Native needs to be able to write the data into the object storage, and then the Databricks or Snowflake needs to be able to read that data out of object storage. So you have multiple permissions on the object storage side that you have to set up. But I have tons of videos showing how that whole process works for Snowflake, Databricks, and Amazon S3 tables. All three of them. I have YouTube videos on, some of it is the setup, and then there's more deployment. So today I didn't show any of the deployment process. Um, and then right now it's always done as a BYOC option. So it's going to be in your cloud provider, but we manage both the cluster and the underlying resources. So the Kubernetes cluster that it runs on, type of thing. And then there'll be observability installed with it. So um, if you have any questions on the BYOC as well, I would encourage you to book a demo as well. But it's been very exciting to be able to see how you can, within 30 seconds, a minute, get that data over. And if you need it faster, they can tune that. But again, you're going to end up with smaller Parquet files, and then you're going to have to make sure that you are in a mode that is going to be able to do table maintenance on it if you're going to want to compact those files down again in the future. That's all I have. I think that answers all the questions that came in. Again, if you have any questions at all about it, feel free to email me and I will get you in contact with our product manager, Kundin, who's another moderator today, or engineering. But we do have many customers who are actively working on these table maintenance questions on the best way to further optimize the compaction and things like that after the fact, and whether or not they want to use external versus internal types of tables. So thanks everybody for coming, and I will probably see you as a moderator in some of the later sessions. So thank you.